Welcome back to the Ephemeris podcast. I'm your host, Aphelion. Thank you for joining me after a tiny hiatus. I apologize for not having released an episode last week. I should have anticipated that I would be busy, but hadn't done so I was not able to drop an episode last week. But we're back, and it's time to get back on track with 3 more pieces of science news to uncover, which has been the theme of the episodes for season 3 so far if you are new here. So, the first article that we're going to be talking about today is a gas cloud near the Andromeda Galaxy. The second article will be about primordial galaxies, and the third article is going to be about luminous blue compact galaxies. So, our theme, in a sense, our theme is going to be about galaxies today. So, the first story of the day, this faint gas cloud that was found near the Andromeda Galaxy. The world of astronomy, kind of ironic to put it that way, is very familiar with the Andromeda Galaxy. It might even be considered the most important galaxy in the universe, other than the Milky Way, because it proved the idea of galaxies themselves. We've talked about that a little bit on this podcast before. If you have no idea what the Andromeda Galaxy is, it's a barred spiral galaxy, which is the closest neighbor to the Milky Way. It is about 1 trillion solar masses, and I believe the method that's used to calculate that is virial mass, and that just shows you how crazy astronomy is at even the most basic levels. Like, the sun is very large to us. It's huge. And so to take 1,000,000 of these suns and then take 1,000,000 groups of 1,000,000 suns and put them together into one huge object with a halo and a bulge with globular clusters, it seems quite unfathomable, but that really is what the Andromeda Galaxy is in a way. So despite all the information we have about Andromeda Galaxy, an article has uncovered something never seen before near the Andromeda Galaxy, which is quite interesting. Like, you'd assume that we'd have figured out everything that there is to know about the Andromeda Galaxy, given it's so close to us. But this article has something else to say about it. It begs to differ. So, amateur astronomers found a gas cloud near the Andromeda Galaxy. We're going to say near because the proximity does indicate that theories will, try to, will maybe make this seem a little bit like not the case, but we're just going to call it a gas cloud near the Andromeda Galaxy. It's not necessarily anything like the Magellanic Clouds like we talked about last episode, but just, I guess, in a sense, a nebula nearly the size of Andromeda itself, or, its length sort of spanning the size of Andromeda as we see it. It was discovered by Marcel Dreschler and Xavier Strautner alongside Jan Sainty. And at first, they actually thought it was an artifact in the lens, and I mean, you can't really blame them. It's like it was very faint, which we'll talk about in just a moment, and just for the fact that we've observed Andromeda Galaxy so many times and we've never seen it, it's like pretty reasonable to see that you might think it's an artifact in the lens. So, because they thought it was an artifact in the lens, they had to have somebody verify it for them, and a 4th astronomer came in, whose name was Bray Falls, and he verified it. So, there's a very wild backstory to finding this gas cloud in itself. But let's talk about it. We don't actually know where it came from, and that has a lot to do with the fact that we don't see a lot of hydrogen in it, right? A quote from the article goes as follows. Its proximity to Andromeda in the sky would strongly suggest some relation to the galaxy, and the cloud is gently curved as if bulging away from the galaxy. Neither of these properties conclusively ties the cloud physically to the galaxy, but both are certainly provocative. If SDS-01, which is the name of the gas cloud, is truly part of Andromeda but outside of the galaxy's main body, that would mean the cloud is tens of thousands of light years long, making it one of the Andromeda's largest coherent structures. And if it's inside of the galaxy and in the halo, which I'm talking about outside of the quote, then, well, no, because it would have copious amounts of hydrogen from stellar ejections, which wasn't observed, or, like stellar activity, not necessarily ejections or anything, but stellar activity, like, it comes from stars. So, it's possible that it's, not a part of the galaxy's main body, but that would make it huge, and if it's inside, well, that doesn't make sense. So we could try to say it has some correlation to the proximity of the Milky Way galaxy and the Andromeda, and sort of the interactions that are going on with the two, which, if you've heard a little bit about Andromeda and the Milky Way and their interaction, you'll know that they're set to collide. But anyways, that's beside the point. There is another theory that goes that, the gas cloud could be the result of these interactions between the two galaxies, but that doesn't make sense because we established earlier that it seems so close to Andromeda, and so that doesn't really check out. Another quote that I'm going to pull from the article itself. Another possibility is that the cloud is physically far smaller but much closer to us, meaning it's a nebula in the Milky Way that is only coincidentally appearing near Andromeda. But again, none of these explanations clearly justify the lack of hydrogen, which is just a piece of analysis about that quote. So the article also continues, it's possible SDS-01 could be the remnant of a Milky Way star that exploded as a supernova, but then it should also be glowing in ultraviolet light and radio waves. Searching older observations of Andromeda, however, astronomers see nothing coming from the cloud at any other wavelengths, including X-rays and visible and infrared light. So, lots of different theories, but it's still very, very confusing. This gas cloud of ours is not really fitting into any intuitive theory we might have for it. That's really odd. And yeah, there's some other stuff that makes it really, really a lot weirder. And I mentioned it at the beginning of this discussion. I'll pull a couple of quotes that'll explain it in further detail. The total observation time in the discovery and confirmation images that used just the doubly ionized oxygen filter, which is how they observed SDS-01, was a staggering 160 hours. That is a long time for observing a gas cloud in the Andromeda galaxy. Like, that tells you about how faint the gas cloud actually is. And even the 3.8 meter Canada-France-Hawaii telescope, which is equipped with an incredible 378 megapixel camera and an oxygen filter, looked right at the spot in the sky where SDS-01 sits and saw nothing. So, a huge mystery with all of this information that we've talked about so far, because no intuitive theory for it, lack of hydrogen, which is like so weird, and it's super faint, which kind of explains why it's never been seen before. But there is a way to crack this code according to the article, which it concludes with. By carefully examining the spectrum of SDS-01, the velocity of its gas can be determined via the Doppler effect, the slight blue shift of its color if the gas is moving towards us, or the red shift if it's moving away. If the cloud is moving at a similar speed as Andromeda, then it's likely to be a part of that galaxy. If instead it's moving more slowly than it's likely to be inside our own. The study's authors report that such spectral observations are already underway, but until those are finished, the origin and behavior of this cloud will remain an enigma. So yeah, very, very interesting stuff going on with Andromeda. So, with that, it's time to move on to our second article, which is about primordial galaxies and this discovery of a Milky Way-like galaxy that is about 12 billion light years away. Before I analyze the article, I do want to talk about primordial galaxies and what they are. There's not like an extensive like what is primordial galaxies, because it's really just a subset of galaxies we observe. But you know, it's important to talk about what primordial galaxies are. So, in the most basic sense, they are galaxies which formed very early on in the universe. They have a large redshift value, otherwise known as a high Z value, because Z indicates redshift, or is the sort of the variable that signifies redshift. Observing primordial galaxies gives us a look into what the universe was like when it was only millions of years old, because the light we receive from these galaxies take billions of light years to reach us. Primordial galaxies allow us to peer into an era of the universe known as the epoch of reionization. This is a time when the universe was filled with cold hydrogen gas and began to ionize with more stellar objects like quasars and dwarf galaxies, and I forget what the other one is. It was population 3 stars, yeah. Which, you know, is a possibility for the epoch of reionization. So, primordial galaxies, with that being said, are very cool structures to investigate. What's really nice as well is that the James Webb Space Telescope, or with it, we are able to look further back in time because its range can observe light from farther back in the universe than, say, Hubble. Recently, we've been able to observe luminous primordial galaxies with possibly population 3 stars, which has really picked up a storm a bit in the science news space. But there are other things we have unraveled with the observation of primordial galaxies, one of which is contained in today's second article. Astronomers have found a Milky Way-like galaxy from 12 billion years ago. A quote pulled directly from the article states, "The galaxy named SBT 041847 has 2 hallmarks of our galaxy, including its rotating disk-like structure as well as the bulge, or large group of stars corralled around the galaxy's center. This bulge of star has never been seen this far back in the history of the universe." So yeah, some kind of groundbreaking stuff, because you have to understand that the underlying assumption about primordial galaxies is like, it was really, really chaotic. We assume that it doesn't have much order because it's during a time where stellar evolution is a little bit different, and galactic evolution, for that matter, is also going to be a little bit altered. But the fact that we're seeing, oh, you know what, this thing actually has a bulge, quite like our Milky Way galaxy, and the disk-like structure is quite well defined. It seems like these primordial galaxies are not exactly what we thought they were. And it isn't like the galaxy is an anomaly among its peers. It's actually quite similar to them. And as I said, not any bit of the chaotic we might associate with the early universe. So the elephant in the room with this with all of these observations of like really luminous primordial galaxies that we didn't think was possible, and SBT 041847, we have to sort of think about how this is possible. How are we getting such an orderly organization of galaxies so early on in the universe if we assume this era of the universe to be very, very chaotic, the epoch of reionization? We don't have a clear answer. And, that has a lot to do with the fact that these articles are recent. And if something's not conclusive, there has to be time for these things to be figured out. And yeah, so it's kind of up in the air, but one thing is for certain, and that is that these discoveries will cause us to shift our ideas of the universe somewhat. We sort of have to register a little bit that even 300, 400 million years ago, the formation of galaxies like our own was possible. And so the theory is going to have to adjust a little bit to that. We have to also look closer at quasars, dwarf galaxies, and maybe even population 3 stars to bring ourselves to a conclusion on this matter that would incorporate the fact that galaxy formation like ours was possible back then. So yeah, just a really quick tidbit that was specifically about one primordial galaxy that was observed to be quite like the Milky Way, but encapsulating the idea of primordial galaxies and what we should think about them. The third article is also going to be a small tidbit. It was published 2 days before this episode releases, but it's about Hubble seeing a merged galaxy, which is quite surprising because all the rage is about James Webb Space Telescope at the moment. So the object that Hubble has taken an image of and in a way discovered more about, it's called ESO 185 IG013. Very funky names today, but I mean that's just how the taxonomy of astronomy goes, if that's even a thing. It's this object that we have that we're talking about, that Hubble has gotten an image of. It's a luminous blue compact galaxy, and like luminous blue compact galaxies is actually something I have not heard about before, and I thought it would be nice to talk about it in today's episode. So what is a luminous blue compact galaxy? Well, the name tells you most of the story. It's a small galaxy which contains large clusters of young, hot, massive stars. So yeah, it doesn't have a fixed shape due to the fact it's made up of a lot of clusters. And so that's the story that the name tells you, but what the name doesn't tell you is that, I don't want to say LCGBs because I feel like that's a bit of a long acronym. Perhaps we can say luminous CBGs or CGBs. So luminous CGBs tend to give birth to violent stars and consume gas very quickly, or at least stars that are violent in their formation. And they're a unique, or luminous CGBs are a unique type of starburst galaxies. So another thing I should know actually is that luminous CGBs are usually considered dwarf irregular galaxies or dwarf lenticular galaxies, but will obviously be distinguished from such for the purpose of today's episode. So with that, let's discuss the fresh take that our third article brings to luminous compact blue galaxies. Hubble imaged ESO 185 IG013 in ultraviolet, visible, and infrared wavelengths to reveal details about its past. Hundreds of young star clusters, many of which are younger than 100 million years, populate the galaxy. So about what we would expect from a luminous compact blue galaxy, but nonetheless, some facts about this object that we're talking about here. The large number of young star clusters indicates that this galaxy was a part of a recent galaxy collision and merger. The perturbed structure of the galaxy, which likely occurred from the violent interactions of gas and dust during the collision, is another sign. The merger supplied the system with lots of fuel for star formation, which continues to take place today. So Something interesting, because with luminous compact blue galaxies, we don't expect sort of the star formation or the high rate of star formation to last very long, sort of in the range of, what was it, 100 million years? Um, so, yeah, the fact that we have a galaxy interaction that's bringing it more fuel might make it an interesting object to observe and sort of investigate galaxies' collisions in themselves. Because, I mean, hey, it's a pretty small galaxy, and if it's going to run out of fuel, then whatever. But if we get more information about, like, galaxy collisions and how they might affect such small stellar objects compared to regular spiral galaxies, we might have more to uncover about the universe. So some other stuff that is mentioned about ESO 185 IG013 is that it contains a tidal shell, and it has a diffuse glow surrounding its bright center, which is a common signal for galaxy mergers. So some characteristics of a galaxy that might come in as a result of mergers. And all of the stars in the system have a combined mass of more than 7 billion times that of our sun. The system is located about 260 million light years away. So 7 billion times obviously being a lot smaller than our closest neighbor Andromeda, as we talked about, but quite distant, and might tell us about some other areas of the universe that we don't have information on. So yeah, interesting stuff. Nothing extremely insightful, even though I'm trying to really make it insightful. It's more of a if you don't know, now you know kind of article. If you do want a little bit of insight, though, that comes from the article directly itself. Here it is. Astrophysicists study BCGs because they provide a relatively close-by equivalent for galaxies from the early universe. We've been talking about that this whole episode, so there you go. This means that BCGs can help scientists learn about galaxy formation and evolution that may have been happening billions of years ago. So, yeah, lots of stuff in today's episode about the early universe, bringing in some interesting galaxies that I've never actually heard of, and really sticking to the theme of discovering more about galaxies themselves. So yeah, that's all I've got for you today in this 4th episode of the Ephemeris podcast in the new season. Let me know in the comments if you are enjoying these episodes, and maybe if you want to see some certain themes about these articles. Let me know in the comments. If you all enjoyed the podcast episode, nonetheless, I would appreciate a subscribe on YouTube or a follow on Spotify, depending on where you're listening. And until the next week, where we bring in a couple more articles, I will see you all later. Peace.